Today we're still solving systems, but instead of solving with either graphing or substitution, today we're going to solve with linear combination. We are essentially going to add our system together, watch a variable disappear, and solve for the one that's left. So take a peek at number 1, and I can add these equations as is together, and notice what happens. 3x plus 6x gives me 9x. Negative 5 plus 5 cancels. And 11 plus 7 is 18. Now to get my variable alone, I divide both sides by 9, and hopefully you'll agree with me that I get x equals 2. Now at this point, it doesn't matter which equation I plug the x equals 2 into, I'll get the same answer either way. So let's use the first equation. I'll say 3 instead of times x times 2 minus 5y equals 11. Here this 3 times 2 is 6. Subtract 6 on both sides and I get 5. Divide both sides by 5 and y equals negative 1. In point form, we would call that solution 2, negative 1. All right, number 2. Now notice in this equation, I can't add them together and have a variable cancel. So I'm going to have to do one step first. I'm going to erase my above example and scoot this up just a little bit. Notice that I could get these y's to cancel if this y was negative, or I could get these two x's to cancel if this x was a negative 2. So I'm going to go with canceling my y's, and I'm going to multiply both sides of my equation by 7. And I rewrite my equation. I have 14x minus 7y equals 56. And I rewrite the other equation as it is right below. Now when I add these together, please notice that your y variable will cancel. And what is 14x plus x? Hopefully you agree with me, it's 15x. And over here, what's 56 plus 19? Hopefully 75. Divide both sides by 15, and what is x equal to? Hopefully you agree it's 5. Once I've found x, I can plug it back into either equation. This time I'll go ahead and plug it back into my second equation. And now I'm going to subtract 5 on both sides and get 14. Divide both sides by 7, and y equals 2. Now that I have my two values, I can write it in point form. Oops. 5, 2 should be my solution. All right, I believe, oh no, I'll do a few more for you. Let's try one more. Let's look at number 3. If I add these together as is, nothing's going to happen. So let's try to cancel these x's. I notice that if I multiply both sides of my equation by a negative 3, that I would get a negative 9x, a negative 12y, and a negative 15. When I combine these together, here they cancel, oh, everything cancels. I end up with 0 equals 0. What do we know about that from the previous section? That it's a true statement, and so my solution are all reals. All right, let's try 2 more together, and then I'm going to want you to try number 6 on your own. Number 4. In order to add those together and have a variable cancel, what would I multiply by? I'm going to multiply this top equation by 2, and I get 10x minus 12y equals 6. When I add those two equations together, my variables cancel for y, and I get 12x equals 18. Oh no, we end up with something we don't really like. Nobody really likes ending up with decimals, but we're going to have to get okay with that. A lot of your solutions in this section will be decimal answers. Divide both sides by 12, and x equals 1.5. Now I can plug this value back into either equation, but I think I'll go ahead and use the second. And I get 2 times 1.5 plus 12y equals 12. 2 times 1.5 is 3. Subtract 3 on both sides, and I get 9. And divide both sides by 12, and what does y equal? Hopefully, you agree with me that it's 3/4 or 0.75. And again, I'd like us to go ahead and write these in point form. Here's my x value and my y value. Oops. And that is my solution. Now for number 5, this last one here, this one seems difficult because we're dealing with fractions and nobody likes to deal with fractions. But we're going to go ahead and add these together, watch the b values cancel, combine the a's, and get a common denominator and combine my fractions. Hopefully you'll agree that the common denominator would be 12, this one would be 4/12, and this one would be 3/12. Combine those together and I get 7/12. To solve for a, I'm going to have to divide by 2, which is the same as multiplying both sides by 1/2. Here it cancels and I get an a value equal to 7/24. Finally, I need to plug it back into an equation and solve for b. Let's do it in the first equation. My first equation, I had a, or 7/24, plus b equals 1/3. To solve for b, I'm going to have to subtract 7/24 on both sides. Here it cancels and it will leave me with b. And here I'm going to need to get a common denominator. 1/3 was actually 4/24. And so when I subtract those, I get a negative 3/24. Can I reduce it all? Absolutely. That's going to reduce to a negative 1/8. So a little bit trickier when we deal with decimals, but not that much. If your equations are not in XY form, you don't have to rewrite your solutions as a point. All right, that will go for your solution in number 6. I'd like you to give it a try and turn it in on a sheet of paper for me tomorrow morning. I'll see you then.